Good morning, students. This is Murthy sir. In the last class, we discussed about the salient features of valence bond theory, the sigma bond and pi bond, and some examples of orbital overlapping. Today, we will discuss about hybridization concept in chemistry and some practical examples. Students, hybridization theory in chemistry was proposed by Linus Pauling. Linus Pauling was the only scientist in the history of science who received Nobel Prize 2 times individually. Basically, hybridization is intermixing of atomic orbitals of different shapes and nearly the same energy to give the same number of hybrid orbitals of the same shape, equal energy and orientation, such that there is minimum repulsion between these hybrid orbitals. Students, today we are going to discuss 3 types of hybridization: sp hybridization, sp2 hybridization and sp3 hybridization. All the 3 types, practical examples we will see. Students, in case of sp3 hybridization, the shape of the molecule will be tetrahedral. Number of orbitals participating in hybridization will be 4, 1 s orbital and 3 p orbitals. In case of sp2 hybridization, the shape of the molecule will be trigonal planar. Number of orbitals participating in hybridization will be 3, 1 s orbital and 2 p orbitals. In case of sp hybridization, the shape of the molecule is linear and the number of orbitals participating in hybridization will be 2, 1 s orbital and 1 p orbital. Students, here you can see the hybridization in beryllium chloride, BeCl2. The bond angle is 180 degrees and it's a linear molecule. Students, earlier in VSCPR theory, we learnt about bond angle and shape of beryllium chloride. Type of hybridization is sp, bond angle is 180 degrees and molecular geometry is linear. Students, the electronic configuration of beryllium is 1s2, 2s2. During the formation of beryllium chloride, beryllium atom bonds with 2 chlorine atoms with the help of a single covalent bond. The number of electron pairs around the central atom will be 2. No lone pair is found in this molecule. Students, beryllium chloride molecular geometry is said to be linear with a bond angle of 180 degrees. It is a non-polar molecule because they have less attraction between each other. Students, beryllium atom in its excited state allows its 2s orbital and 2px orbital, which contain unpaired electrons, to intermix and redistribute to 2 identical orbitals. Students, this is the hybrid structure of boron trifluoride, BF3. The bond angle is 120 degrees. Students, in case of boron trifluoride, the molecular geometry is trigonal planar. Type of hybridization is sp2. Bond angle is 120 degrees. The electronic configuration of boron is 1s2, 2s2, 2p1. Students, in case of boron trifluoride, boron's atomic p orbitals and s orbitals in the outer shell usually combine together to form 3 sp2 hybrid orbitals, which are all of the equivalent energy. Students, boron first undergoes excitation to get electronic configuration 1s2, 2s1, 2px1 and 2py1. Students, sp2 hybridization is observed when 1s and 2p orbitals of the same shell of an atom mix to form 3 equivalent orbitals. The new orbitals formed are called sp2 hybrid orbitals. Students, in case of boron trifluoride molecule, 3 sigma sp2p bonds will be seen. Students, this is the hybrid structure of ammonia, NH3. Students, the bond angle in ammonia is 107 degrees 48 minutes. Students, the molecular geometry of ammonia is pyramidal. During the formation of ammonia, one 2s orbital and three 2p orbitals of nitrogen combine to form four hybrid orbitals having equivalent energy, which is then considered to be as an sp3 type of hybridization. Students, you know the electronic configuration of nitrogen is 1s2, 2s2, 2p3. Four sp3 hybrid orbitals of nitrogen atom of ammonia is formed by the overlapping of three half-filled orbitals of nitrogen atom with s orbital of three hydrogen atoms. There remains a full-filled sp3 hybrid orbital. The molecular geometry of ammonia is pyramidal or distorted tetrahedral due to the presence of lone pair. One lone pair is seen in ammonia molecule. Students, in case of water molecule, two lone pairs will be seen. This is the hybrid structure of water molecule, dihydrogen monoxide, IUPAC name of water. Students, just like ammonia, water molecule also shows sp3 type of hybridization. Students, in water molecule, hybridization orbitals having the same energy level will combine to form hybrid orbitals. The water molecule has two lone pairs and two bond pairs. Each oxygen and hydrogen covalent bond is called a sigma bond. Students, in case of water molecule, the type of hybridization is sp3, bond angle is 104 degrees 31 minutes, and the molecular geometry is V-shaped or bent-shaped or angular-shaped. Students, in case of water molecule, it has a tetrahedral arrangement of the electron pairs about the oxygen atom that requires sp3 hybridization. Two of the four sp3 hybrid orbitals are used to form bonds to the two hydrogen atoms, and the other two sp3 hybrid orbitals hold the two lone pairs on oxygen atom. Students, in case of water molecule, due to the lone pair repulsions and lone pair bond pair repulsions, the bond angle decreases from 109 degrees 28 minutes to 104 degrees 31 minutes.